Hi everyone, Dan here from HackstreamING, bringing you another easy beginner level try hack me room. This one, just a little bit of fun. This room is called Capture the Flag. It's beginner level CTF challenge. This particular one, we don't need to be on the VPN and we don't actually have a machine to start. So this one's just got some fairly typical tasks that you might find in a CTF. Changing encoding on strings to get flags, some stuff from a spectrogram, bit of steganography, and then looking into some security through obscurity. The last three tasks have some download files, but the first one just gives us some strings of characters. Typical kind of translation tasks that you expect to find in a CTF. The first one's going to be pretty easy. We can probably just read what that is. That's just your standard kind of elite speak. So I'm guessing that's going to be, can you capture the flag? It is. And the next string looks like it's going to be binary. And there's quite a natty little tool, which I think is in Kali Purple. If you ever do the Kali Purple build. But also online, this is a tool called CyberChef, which is really useful, especially for these kind of challenges. So this should let us rip through this pretty quickly. We'll take text there. So CyberChef has it can encode lots of stuff, it can do lots and lots of things, and as the series goes on, we'll use this quite a bit. It's a tool that I use quite often. But one of the options that it has in the favorites is this magic recipe, which gives you an idea of what something is likely to be. And I often use that if it's something that I don't sort of recognize, I'll use this as a nice easy way to try and get help. But you can see from the recipe there, it's from a binary, and click that. Shows us the tool, so that will be flag number 2. Okay, we'll have a look at this one. Didn't actually set my room up earlier, but here we go. So we'll have a look at this. We'll use some of the built-in tools for some of these. On the surface, that looks like it might be base 64, but if you look closely, you'll see that it is all capitals. It doesn't look like there's any numbers other than sort of between 2 and 8. So I think that's probably not base 64. Base 64 gives us something different. I think that's going to be base 32. That magic tells us, yeah, base 32. Look at the base 32 character set. Similar to base 64, uses half the number, and the characters are capital letters A to Z, and the numbers 2 to 7. So if we go back to our flag, if we go back to our text there, we can see what we got there is a 4 and 2, and a 6 and a 3, and another 2 and a 5. So we can use base 32 to solve that one. Okay. What about this next one? So again, this looks passingly similar. Base 64 uses 64 characters. Same thing. Chuck that into CyberChef. Magic's going to tell us it's base 64. But we can also use command line tool built into Linux, and we can get our flag that way. This time around. So what about this one? So there's a good chance this might be hex or base 16. There you go. This next one, it's not hex. So it's rot 13. Just a straight rotate right and rotate left. They did some other characters. Rot 13 is fairly common. I think this one's probably going to be the same, but this one, I think this is probably also a rotational cipher. And I'd say another one of the quite common ones is ROP47. These are just the you just kind of get used to seeing these after a while. Just get used to seeing some kind of character encoding. Just kind of put two and two together in CTFs. CyberChef is a really cool tool for this kind of task. You can get local versions. This one obviously is the live web version. What do we have here? So this is telecommunication encoding. So this is Morse code, dots and dashes. What about this one? This one is just straight decimal. Sometimes in CTFs, people mess with the encoding or the delimiters or various things. Try this again. So let's copy all of our text from here. Check the equals on the end because it didn't copy. So we believe this is base 64. Okay. From base 64. Base 64, which gets us to Morse code. Morse code gets us to decimal. Decimal gets us to a problem. And I think the problem is going to be the spaces. So go find replace, and we will find a space and we'll replace it with nothing. Right, and now let's go Let's find sometimes with my VM, my keyboard input does a weird thing and sort of types backwards. And I think that's likely to be one of these. Not that one. Let's try 14. Okay, which gets us to decimal again. And then let's go from decimal. Cool. So that was a whole bunch of the other encoding just layered on top of each other, which is pretty cool and also pretty common in CTFs. The base 64 decode that it did in Rick and Morty, a similar sort of thing. But it was just base 64 layered on base 64 layered on base 64 for ages and ages. Pretty typical kind of stuff in CTFs. Come on, shivered browser. There we go. Cool. So there is our translation and shifting section done. Next we're looking at a spectrogram. So a spectrogram, visual representation of frequency of a signal. So for this, we're going to need a program called Audacity, which I have already installed. We'll run. So, and then we'll open secret audio file. Okay. And we actually want to look at the spectrogram rather than the waveform, which gives us this, which is pretty cool. So that says super secret message. There we go. So our next task is steganography. So we'll just download our image, same thing, pull it over here. So we'll just have a look at our thing here. It's a little stegosaurus and a plate of spaghetti. So steganography is basically encoding secret data into image files as a way of transferring secret messages and stuff. There are a bunch of steganography tools, which I thought I had installed already, but maybe I haven't. What's a good one to do? Stegcracker, Steghide. Steghide's pretty good. Steghide. Yeah. Stegseek, I think, has been deprecated by the author. No, okay. So let's go without a word list. I think without a word list, it might use robots. Not robots. RockU, or one of those things by default. Let's have a look at spaghetti stig. Tool I do. Quite often in CTFs as well, where you've got image files, there might be stuff hidden in the EXIF data. Often you'll find like a base64 string. Go back here, submit our file, and then we're on to our last section, which is security through obscurity, which is going to give us a JPG file. So let's go and have a look at this. See what that does. Let's have a look at the EXIF data and see what we've got in here. Okay. See if we have anything in there. Nothing in there. Obscure stick. StigSeq didn't find anything. Dig. Meme. Is it a double dash? Can't get it out without the passphrase. 0 embedded files. So there was nothing in the EXIF data. What about signature dumb? Now what do we get out of that? We've got hackerchat.png. Okay, so we have a file in there. So let's do the same stuff again, except that I don't think PNGs do steganography. Let's do StigSeq. Chat, yeah. So PNG is not a supported file. Can we look at it with a text editor? Say, can look at it with a text editor. That's probably going to be our thing. We might also be able to use strings and get it that way. Can. There we go. Done and done. A couple of those tasks took a little bit longer than expected, but they're the kind of things that you'll often come across and capture the flags. And try hack the box, any CTFs that you might do. Good times, good fun. Thanks for joining me. See you next time.